Alright, so here's my small scale timbering set, and looks a bit wonky, but doesn't really matter. It's more to work out strength. I'm going to see, that's what you call lagging. I've put the top lagging up already. I'm going to put the bottom, and that's just there for support. I've nailed them in too, kind of nailed it in so they can't move as much. And I
won't pull it out now because I've got to do the rest of it, but I've made the legs pointy at the ends. This is just so they stick in the ground. I wouldn't do it when I'm sticking them in for real, because you need all the strength you can at the bottom and the top. And they're just notched in there and on that side over there, like you would in a normal real life set. Put them on the angle grinder and did it. What I want to try is different methods. This is going to be the first. This is the more basic kind of method. Then go from there and maybe do like triangle type of one method, and then close set timbering where you have the legs and the cap really close together, a lot closer. Yeah, and then see what's the strongest, and then employ that in the real world.
So this is just a start of a few small scale tests, just to work out what's going to be the strongest. Okay, so now you can see I'm putting the lagging on both sides of it, and this is how it would probably be like if it was in the mine. What I've now got to do is put some more mine plank. I'm using icy pole sticks, but it's called mine plank, on the top, and then dirt over the top of the mine plank, and then I'm going to test it out and see how strong it will be. And this is just only sand that I've used on the sides.
I'm now going to test it with a bucket on top, and that's going to be filled with water. So that's a full container of water. So far,
so good, which is pretty impressive. It's a small scale test. I mean, you can see the sticks. They're not really thick. They're not really thick at all, but they're supporting all that weight. So that's a good thing. So at least I've done something right. It's on an angle because I didn't really put the sticks correctly, the right height, so it's a bit of on an angle, which I know will affect the strength of the whole lot. But it's pretty amazing seeing that holding. I might add a little bit more water just to the top of here and see what I can do. Yeah, that's pretty amazing. As you can see, the sticks, they're not really thick. They're that thick there. But that's all, there's 4 of them, and that's all that's holding this container above with the water in it. So that's pretty impressive. Alright, so I've just put a log, kind of a log on there. Just put a log on there.
And it's still holding, but I've noticed that if you move it slightly sideways, the whole lot starts to go, the whole lot starts to fall. This is still pretty impressive.
So that's holding a lot of weight. For a small scale test anyway, holding a lot of weight. So I've got to be careful now because she's almost ready to fall over because I've got no side bracing. So if I move it backwards or forwards like that way, kind of, or sideways like that, she'll fall. It'll just fall. But that is pretty impressive. For small scale, that's pretty impressive.
That's hardwood too, by the way. That's not pine, so that's quite heavy. So if I push it one way or the other, just gently, the whole lot goes. I think, to be honest, I think I need to test it with a full 44-gallon drum full of water. Then it might break with the cap piece. Yeah, so if I just kick that, the whole lot's going to fall over. But the thing I want to try is I want to figure out how much weight it will take to actually physically break those caps, the actual cap pieces. Whereas at the moment, if I kick it, it will fail due to being no sideways support, which is understandable because if you don't have sidewards, like something sideways up against the little legs, the whole lot just goes.
So that's what I need to find out, how much weight I can physically put on it for the actual cap piece to break. Alright, so I've just put this car brake on it, on top of the wood, and the whole lot, as I said before, the whole lot went sideways slightly, which I didn't want to happen, and it's completely crushed. That happened because it went sideways and there was no sidewards, there was no supports for the sides, except for the lagging, but there was no supports to keep the posts in place where they should be. So, but that is pretty impressive. Held a lot of weight, and it didn't actually, as far as I know, I'm going to check it now, as far as I know, it didn't actually break any of the supports, but I will check that now. As you can see, that's all lagging, and the actual cap piece, that's just all lagging. The actual cap piece here,
that's the cap piece there, didn't fail, that didn't break. See that? It didn't break at all. I've just nailed it on for strength too, but that didn't break, and that was holding a lot of weight. That was holding a lot of weight. Didn't break. Very impressed. The amount of weight that held. See if I can find the other cap piece and legs. They're trapped underneath all the sand. Neither did this. Got to find the leg, but there's a leg. Okay, so there's a leg. This one didn't fail either. Didn't break. I'm not worried about like they've come loose off there because that's not what I'm after. What I'm after is signs of cracking in the corner there. That's the cap piece there, and signs of failure in that one spot there. And as far as I can see, there's no cracks in that at all, which is very, very good. Same with these two. No cracks, apart from what I've already done previously, which is a nail there. But that's all right. That's nothing. So you can see how they kind of fell over. I'll give you a demo. If you can imagine, they went that way. So there's no supports holding them from going that way. There's support going that way. So if they wanted to go that way, it's a lot harder because there's a lot more resistance going that way. But going that way was the easiest way for them to fall over, and that's what happened after I put that steel brake disc on top of everything else, plus the water. It's a few kilos there too in the water. It's quite heavy. So that was the failure on the small scale test, which to fix that you put sprices, I think they're called splicing, like bracing. You put bracing across to each set. So if one set wants to kind of fall over, it has to push all the rest of them over before it can push the one that wants to push over.
If that kind of makes sense. So that's what I've learnt so far, which is interesting. I need more bracing on the sides before I can ramp up the scale and put, like, you know, the weight of a 44-gallon drum full of water on it. That may actually break the cap pieces there, but I don't mind, because that's what I want to try. I want to see what weight it will take to break the cap piece and or the leg.